Hello. I would like to go over one exercise on page 524. This is number 7 on page 524. Okay, in this exercise, they want us to use the 4-step process to find f prime of x. That's the symbol for derivative, okay? The 4-step process is on page 520. So those 4 steps are basically the rise over run formula that we saw before, and then at the end you take the limit when h goes to 0. Okay, so that's basically what that process is, but we do step by step. First we find the first y value and then the second y value, subtract, that's the rise, and then the run is just the h. Okay, so you divide the rise over run, and then the final step you make h go towards 0. Okay, you make h approach 0. Okay, so let me show you how to do that. So just to recall that the function there that they give you is 3x minus 7. Okay. Now notice that that function is a linear function, so that's the type of function that you learned before in algebra. 3x plus minus 7, you know the slope of that function, the slope is 3, right? This is the y-intercept. We know that this is a line, straight line, goes upward. The slope is 3. So the slope at any point on that line will always be 3. Okay, so we could answer this question very easily by saying, well, the derivative is 3. Okay, the derivative is a slope. But let's try to use the formula so you can practice. Okay, so because not everything will be linear like this one. So they want, so this is what they want. They want a formula for the derivative. Okay, so this is derivative of f of x at x, at any x, could be, so you're going to find a formula. Before we found the derivative of f at 1, x equals 1, or at x equals to 2, or at x equals to 3. So, but we don't want to do that every time we change the value of x. Okay, so we need to find a formula for the derivative, and then at the end we just plug the numbers in. So let's use the 4-step process. First I need to compute, so basically the idea of the 4-step process is to find, so first you find rise, you find rise over run, then you find limit of rise over run when h approaches 0, and that will give you the slope. Okay, so this is what they want. Alright, the first step in that 4-step process is to figure out f of x plus h. Okay, so let's see what this is. Well, here's the function f of x equals to 3x minus h. So let's put that in here, right? So just to make sure you understand how we plug this, so some of you, most of you might understand what I'm doing here. So when you see a function, it basically means that whatever you put in here, you can put the world in there, okay? Star or anything in there. What the function is telling you is that you're going to take 3 and then multiply by whatever this is, and then subtract 7. Okay, so this would be 3 times, and then look at what the input is. It's x plus h. Okay, so whatever the input is, we put that in here. and then plus, minus, right? Minus 7. So now we need to do some algebra here because we don't know what x is, we don't know what h is, okay? So let's expand this. This would be 3x plus 3h minus 7, okay? So that's step number 1. Then they want us to compute what? F of x plus h minus f of x, all right? F of x plus h minus f of x. Okay, well, f of x plus h is already here. See, this one is this one here. Okay, let's put that in here. And then minus, now we need f of x. Well, f of x is given here. So let's put that in here. 3x minus 7. But be careful here because this is minus the whole function. So you need to put parentheses, right? Minus the whole function there. If you don't put parentheses, then we're going to think that this will be minus just the minus 3x, and we don't minus the negative 7, but we have to. Alright, so let's simplify this thing. So that's 3x plus 3h minus 7, right? That's the first part. And then minus 3x, and then minus 7, that's positive 7. Okay, we can simplify this a little bit more. See here, I can cancel the 3x with minus 3x. Look at this, negative 7 with plus 7. All it's left here is the 3h. Very nice. Okay, then the third step is to actually do the rise over run. Okay, so this here was a rise, right? F of x plus h minus f of x. Okay, now we're going to do the rise over run. Okay, that's f of x plus h minus f of x divided by h. Okay, so here's rise and here's run. Run is just the h. Okay, we found this before, which is here. It's just simply 3h. Let's put that in here. And then divided by h. Oh, look at what happens now. That's nice. Simply 3. And then the final step is to know what happens with rise over run when h goes to 0. Well, look at this. Limit as h goes to 0 of rise over run, which is this thing, right? So it's limit as h goes to 0 of 3. Well, 3, you see this formula here, this expression doesn't have any h, so it doesn't matter what happens to h, this will always stay as 3, right? It doesn't matter here. So h can be 0.1, this will still be 3. H can be 0.0001, this will still be 3. So it doesn't matter what h is. So this is just a constant, it doesn't depend on h. So here it is. So this is the derivative of of f of x at x. So the conclusion is f derivative is simply 3. Okay, so this is, don't forget that this symbol here looks like a number 1, but it's not really number 1, it's simply an apostrophe, right? It represents derivative, okay? It's the derivative of f. Every time you see this symbol here, it means derivative of f. Okay. All right, there we go. This is the answer for the first question there. Okay, find f prime of x, or f derivative of x. Then we can use that to figure out the derivative at x equals 1, at derivative of f of x at x equals to 2. So we can figure out all the other ones very easily. And so here, f derivative at 1. Well, here's a formula for u. We found it. What happens if I plug 1 in here for x? It stays equal to 3. Next, f prime of 2, it stays the same, 3, right? If I put 2 here, it stays the same. And if I put 3 there, it stays the same. Right? Okay, so those are the answers for that problem. Okay. Let me go ahead and do another one. Let's see, let me do a more complicated one. Okay, number 9 is, I'll tell you what, I'll do number 10, which is kind of similar to number 9. Okay, I'll do number 10 and then you do number 9. So let me go ahead and do number 10 here. Number 10, this is still on page 524. Okay, again, they want us to find the derivative here. Here's the function, 2x squared plus 8. Okay, so they want the derivative of the function at x. They also want the same thing as before. They want you to find the derivative of f of x at 1. Then the derivative of f at 2, the derivative of f of 3. So they want all those 4. So we need to find this one first, then we can easily figure out the other ones. Okay, let's do this one using the 4-step process. So step number 1, we find f of x plus h. So we need to use a little bit of algebra here, okay? So again, just to refresh your minds about plugging things into the function, right? The input, whatever the input is, right? The function will take that input, will multiply, right? We'll square it, multiply by 2, and add 8. Okay? So that's what this means. All right. So here's the input. So we're going to take that times 2 and squared, square and times 2 plus 8. Okay, so you're plugging this input in here, so that would be 2 times the input squared plus 8. Alright, let's simplify this a little bit. 2 times, alright, x plus h squared. You know, this is square of 2 terms, a sum of 2 terms. So this would be x squared plus 2xh plus h squared. And then plus 8. Okay. And then, so if you don't remember what I did from here to here, just refresh your minds. Try to remember this formula here. A plus b squared. Y'all remember that? A squared plus 2ab plus b squared. Right. So that's what I use here. This is a, this is b squared. It gives me that. All right. Let's do some more here. 2 times x squared plus, and then 2 times 2xh would be 4xh. Then 2 times h squared, that's 2h squared plus 8. Alright, so that was step number 1. Okay, here's step number 2. We're going to take that f of x plus h, which is this thing here, and we're going to subtract f of x. Alright. Okay, here is f of x plus h, which is this expression here. Let me repeat that here. Okay. And then minus the f of x. Okay, f of x is this expression right there. So I need to put that in parentheses. Okay, and then let's see what happens. 2x squared plus 4xh plus 2h squared plus 8, and then minus 2x squared minus 8. Right? And then look what happens here. Things are going to cancel out. This 8 with negative 8 cancels. Look at this. 2x squared cancel with negative 2x squared. I think that's all it cancels, and then let's see what it's left now. 4xh plus 2h squared. That's it. Okay, then step number 3. We divide by h. We divide this by h. That's the rise of a run, right? This is the rise. Here's the run, h. Okay, so divide that by h. Okay, and then here we can do some simplification. Right, I can collect 1h. So there is 1h here, and then h squared, that means that there is hh there, right? So I can collect 1. So I can collect one of them. So put 1h out. This will be 4x plus 2h. Okay, so I collect 1h. So here there's 2 h's there. There's 2 times hh. So I pick 1h and put it out. So that's factoring divided by h. Look what happens. Cancel this h with this. So that's what it's left. Nice. Step number 4. Now let's see what happens when h goes to 0 of this, okay, of the rise of a run. Well, rise of a run. So this expression is actually simply 4x plus 2h, right? Alright, so, well, this is a simple expression. There's no denominators. We don't have to worry about the denominator. We can simply plug 0 in there for h. So this is 4x plus 2 times 0, right? So h goes to 0, we can put 0 there. There we go. So this is just 4x. All right, the conclusion is the derivative of f of x is 4x. All right, so look at this. Here's the original function, right? F of x, 2x squared plus 8. Look at the derivative. The derivative is simply 4x. Then we can use that to compute the other things we want. F derivative at 1, that's easy. That's 4 times 1, right? 4. What is the derivative at 2? That's easy. That's 4 times. This is 2, so put 2 here. 8, right? And 4 times 3, 12. So that answers number 12. Okay.